Hey guys, let's solve this next question. You can just give it a try and you can resume to look at the solution. All right, guys. Now, if you solve this, using conventional inequalities, it's going to be a very difficult process. But if you know the meaning of, or if you know, or if you understand the term modulus in depth, it's a very simple question. So, what exactly does modulus indicate? When I say mod of n minus 60, basically it is the distance between the points n and 60. Okay. So I want a point on the number line. Okay, I am measuring its distance from the point 60. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 up to 60. The distance of this point, okay, 60, I'm measuring, okay, from some point, let's say n. Okay, that is mod of n minus 60. Again, the distance of the same point n, okay, from 100 is being measured. Okay, so 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70 up to 71, 72. This will go on up to 100. Now, this means what? The distance of this n from the point 60 should be less than its distance from the point 100. Now, this will happen when the point n, lies more towards 60 and not 100. So let's first find out the midpoint of 60 and 100, that is 80. So when n is equal to 80, the distance of 80 from 60 and 100 will be equal. But we want the distance of n to be, okay, more towards 60. But we want the distance of this n to be less from 60 units. That means n should be less than 80, right? If n is less than 80, okay, and n is an integer, definitely its distance will be less from 60 as compared to 100. So you can take values and check. If you take n is equal to 79, guys, distance of 79 from 60 is 19 units and 79 from 100 is 21 units. Okay, this is lesser. That's exactly what we want, right? Same way, you can take n as, let's say, 78. Distance from 60 will be 18 and from 100 will be 22, lesser as we want. Okay, and this will go on up till if you take n as 61, distance will be 1 from 60 and will be 39 from 100. Okay, so the first condition we have got is n should definitely be less than 80. Okay, guys, we now focus on the next condition. The distance of n from 100 should be less than the distance of n from 20. So we'll just put 20 here. Now, if n is equal to 60, the distance of n will be equal from 20 and 100, right? 40 units each. But distance from 100 should definitely be lesser than distance from 20. That means n should be greater than 60, right? So n should be greater than 60. That's the second condition which we get. Now, when we combine these two conditions, n should be greater than 60, but n should be less than 80. The integers we require for n are 61, 62, 63, up till 79. So consecutive integers, we have learned this for so many times now, going from a to b. How many integers are there? B minus a plus 1. So 79 minus 61 is 18 plus 1. Total we have 19 possible integers. So how many number of integers n satisfies the given inequalities? The answer is there are 19 such integer values starting from 61 up till 79. Okay. Now you may argue that I have forgotten the last condition, the distance of n minus 20. Okay. The distance of n and 20 will basically be greater than distance of n and 60. Well, that does not give you anything new. Okay. Distance between 20 and 60 will be equal when you take n is equal to 40. Okay. So this distance should be basically greater. Distance of n minus 20 should be greater, or distance of n minus 60 should be less. So n should be more than 40. Well, nothing new. Okay, it is the same condition for n more than 60. So that the comparison of the first and the last part does not give you anything new. And that's why we, just ignore that. The inequality which we need to understand is this. N is greater than 60 and less than 80. Okay, n can take values from 61 to 79. These are 19 integral values.